Okay, here we go. So now let's do a problem. This is another way to talk about our whole idea of inverse sine, but using a physics problem. So this is with refraction, and the idea is this: I give you a problem and say find the refracted angle if the given incident angle is 22.6 degrees, and I'll say that it's white light going in from air to water. So right away you would look at the problem and you say, all right, I know that the incident angle, which is going to be, or the I'm sorry, the index of refraction for air is 1. The index of refraction of water is 1.33. All right, so I have those two n's. So this will be n2, this will be n1. All right, and I need to look for the refracted angle, and the incident angle is going to be 22.6 degrees. So here's what I'm going to do. I'm going to first write the equation. N1 sine theta 1 is equal to N2 sine theta 2. All right. Now, the same thing, 1s and 2s can also be incidence and refracted. We always do 1 as the incident angle and the incident information, and 2 as a refracted. So now I'm going to start plugging it in. So I'm going to say I'm going from air to water. So N1 was 1. Sine theta, so I'm going to put sine theta 1 is 22.6. My incident was 22.6. That would be right here, 22.6 degrees. Where my refracted right there is what I'm looking for. Okay, so I'm going to say 22.6 degrees is equal to N2, which is what we're going into, which is water, 1.33, times sine theta 2, and we don't know what that is. That's what we're going to solve for. So with sines, it's just like the same following the order of operations. We have to take care of the outside stuff first. We got to go outside in. Okay, so the first thing we have to do is divide 1.33 on both sides. All right, so those cancel out. Yoink, yoink. All right, so now I have sine of theta 2 is equal to 1 times sine 22.6 degrees divided by my 1.33. Okay, so what I'm going to have to do is now, again, to undo a sine, to unsign a sine, you do inverse sine. So if I'm going to do this in a big calc, I'm going to show you how to do the whole thing, but then we can go step by step on how to get the number. So I'm going to do inverse sine to both sides. These cancel out, and I only have my theta 2 now by itself, which is what I'm looking for. All right, and now on the other side, I have inverse sine. I have 1 times the sine of 22.6 divided by 1.33. Okay, so that's going to get me the right answer. Now, I need to make sure my calculator, I don't have my good calculator. My calculators are quarantined back in my classroom at school. Okay, but this will do just fine. Okay, so in this one, I have to hit sine last. And a good calculator, which is probably what you have, you could write in your calculator. I'll write it down below. You would hit second sine to get your inverse sine. Parentheses would open up. Okay, I'll slide this up a little bit. And I would then have my 1 times, which obviously 1 times doesn't, you don't need to put that in, sine of 22, you'll have parentheses open up again, 22.6. Make sure you close your parentheses, divided by 1.33. And the calculator would close that parenthesis anyways, but that's what it looked like. So that's what it should look like in your calculator. Just make sure you have it set to degree mode. Okay, in mine, what I'm going to have to do first is my 22.6 degrees first. All right, here we go. So I would do clear 22.6. I'm going to hit sine of it and get that number. I'm going to multiply it by 1, which doesn't do anything. We don't need to worry about that. I'm going to divide it by my 1.33 and get that answer. Okay, so that would be these two divided, and which would be, so now I have inverse sine of 0.2889. Okay, and then all I have to do is hit second sine again, and I can get my angle. So my angle in this case is going to be 16.8 degrees. Okay, so that's what inverse sine looks like when you're doing something with a Snell's law in refraction.